Welcome back to Lecture 3 of Foundation Maths for Chemistry. In this second and final part of this lecture, we're going to be discussing simultaneous equations. Here, you'll learn how to solve simple simultaneous equations by inspection, solve harder simultaneous equations by algebraic elimination, solve simultaneous equations by graphical methods, and finally, solve problems using simultaneous equations. So to start with, let's talk about solving simultaneous equations by inspection. Sometimes you'll need to solve a pair of equations such as 5x plus 2y equals 19 and 5x plus 3y equals 21. These are called simultaneous equations. The idea is to find a value of x and a matching value for y so that both equations are true together. The method of inspection requires you to look at the two equations and spot any obvious slight differences between them. Note, this should only be used for simple problems. So let's look at an example where we can use inspection to solve simultaneous equations. So here we have 5x plus 2y equals 19 and 5x plus 3y equals 21. So let's now try and solve that. So first, you label the two equations 1 and 2, and then you try and compare them. So here we have these two equations. Now the only difference on the left-hand side is that number 2 has an extra y. And the only difference on the right-hand side is that number 2 is 2 larger than equation number 1. Therefore, by inspection, we can note that y equals 2, because the only difference between here and here is 1 extra y and 2 more on the right-hand side. So therefore, as I said, we deduced that y must equal 2. Now, we take the y equals 2 and substitute that into equation 1. So we've got 5x, because we don't know what x is yet, plus 2 lots of 2, because we know y is 2, and that equals 19. So therefore that's the same as 5x plus 4 equals 19. And we take 4 off both sides to give us 5x equals 19 minus 4. And that gives us 5x equals 15. And then we divide both sides by 5 to leave x by itself, which equals 3. So therefore, the final pair is x equals 3, as we worked out here, and y equals 2, as we worked out here. Now it's always good for these examples to then substitute your numbers back in to the equation you didn't use. So we only used equation 1, so let's substitute them back into number 2 to make sure that it works out. So here we've got equation 2, which is 5x plus 3y. So we need 5 lots of x, which is 3, so 5 times 3. I need to add on to that 3 lots of y, so that's 3 by 2. And make sure again we need to do BIDMaths. So BIDMaths says that you do multiplication before addition. So therefore that's 15 plus 6, because we've done the multiplications first, and that equals 21, which is as it should do in this equation. So therefore we know we've got the right numbers. Let's now move on to solving simultaneous equations by algebraic elimination. This method is used for most problems if the answer is not obvious by inspection. The idea is to multiply one or both of the equations by a suitable multiplier until we have a matching number of x's or y's. There are two variants of the elimination method depending on the signs involved. If the matching terms are the same, but one is positive and the other is negative, then you use the addition method. If, however, they are both positive or both negative, then you use the subtraction method instead. A useful rule is DAS. Different, add. Same, subtract. Algebraic elimination. Here's an example. So here we're asked to solve the simultaneous equations. 2x minus y equals 8, and x plus 3y equals 11. So, the first part of the solution. First, we need to label the equations 1 and 2, and then compare them. So here we've labelled the first one 1, and the second one 2. Then, to try and get a similar number of y's on both of the equations, or at least the same number of y's indeed, we've taken the first equation and we've times it by 3. As you can see here, 3 times equation 1, so 3 times 2x is 6x, 3 times y is 3y, 3 times 8 is 24. And then we've left equation 2 the same and brought it down here and just multiplied by 1, so effectively not done anything to it, but here labelled it as number 4. Then, because we've got different signs here, remember DAS, different, addition, same, subtract. So because they're different, we're doing addition. So we've added these two together, so 6x plus x equals 7x, minus 3y plus 3y is 0y, so nothing here. And we add 24 and 11 together to give us 35. And then simply we divide both sides by 7 to give us x by itself, and that gives us x equals 5. Now, the next thing to do is to substitute that x equals 5 into one of the equations. So now here we picked to do it in equation 1. Equally, you could have picked to do it in equation 2. So now, putting x equals 5 into 2x minus y, we have 2 times 5 minus y equals 8. So that's 10 minus y equals 8. And then if we take 8 off both sides, that gives us 2 minus y equals 0. And if we add y to both sides, that gives us y equals 2. Therefore, the final pair is x equals 5 and y equals 2. The last thing you should do is just do a sanity check. So here we're going to substitute our x equals 5 and y equals 2 into equation 2. So therefore we have 5, because that's the value of x we derived, plus 3 times 2, because value was 2, and that equals 5 plus 6, remembering to do BIDMAS in the right order, so multiplication before addition, and then 5 plus 6 equals 11, and does that equal what equation 2 equals? Indeed it does, so therefore we know we've got the right answer. Let's now look at another problem to solve using algebraic elimination. Here we have the example of simultaneous equations of 7x plus 2y equals 24 and 5x plus 3y equals 25. So first we need to number them. So I've numbered this one 1 and this one 2 in the same order they are here. Then we need to try and get a similar number of x's or y's in the two equations. So let's show you how to do this. Well, I've taken the first equation and times it by 3. 3 times 7 is 21. 3 times 2 is 6, so as you can see 21x and 6y. And times 24 by 3. Now times the second one by 2 to give us 10x and to give us 6y, and that equals 50. Now I picked to do this because that was just the easiest way to get a similar number of x's or y's across the two. Equally, you could have times this equation by 7 and this equation by 5, and that would have given you the same number of x's, but the maths behind doing that was just slightly more complicated. So I found it easier to just times the first equation by 3 and the second equation by 2. Either is valid, however. Now, because the signs are the same, you subtract. Remember, DAS, different, addition, same, subtract. As you can see here, the signs are the same, so we subtract. And if you do that, 21x minus 10x is 11x, 6y minus 6y is 0, and there's nothing written here. And then 72 minus 50 is 22, so that gives us 11x equals 22. And then we simply divide both sides by 11 to give us x equals 22 divided by 11, and gives us the answer x equals 2. Next, we need to substitute that x equals 2 into one of the equations. So now you can see that's what I've done. So I picked equation 1, equally you could have picked equation 2, and I've substituted the 2 in. So therefore we have 7 times 2, because it's 7x, plus 2 by y, and that should equal 24. So we have 14 plus 2y equals 24. Then we take 14 off both sides, so it's 2y equals 24 minus 14, which is the same as 2y equals 10. We divide both sides by 2 to give us y equals 5. So therefore we have our pair of solutions of x equals 2 and y equals 5. So all we're left to do is now substitute our numbers of x equals 2 and y equals 5 into the equation we didn't use. So earlier we used equation 1, so now I'm going to substitute them into equation 2. So therefore 5x plus 3y equals 5 lots of 2 and 3 lots of 5. And by doing BIDMAS in the right order, that gives us 10 plus 15, and that equals 25. And 25 is what the equation should equal, so therefore we know we've got the right answers. Solving simultaneous equations by a graphical method. This is quick and simple. It is particularly effective if the answers are whole numbers. When they are decimals, however, it becomes less accurate than the algebraic method. Let's look at an example. Solve graphically the simultaneous equations 4x plus y equals 6 and 5x minus 4y equals 18. So, the first part of the solution. Consider first the equation 4x plus y equals 6, when x equals 0, 4x plus y equals 6, so therefore x equals 0, we'll cancel this bit out. That gives us y equals 6. Thus the graph passes through the point 0, 6. Now if we do the same bit for when y equals 0, that gives us 4x plus y, which you know is going to be 0, equals 6. So therefore that gives us 4x is going to equal 6, giving us x equals 1.5. Therefore we know the graph will pass through the point 1.5, 0. If we simply plot that, this is the end result. As you can see, the 1.50 point here and the 60 point here. Next, let's consider the second equation. So the second equation is 5x minus 4y equals 18. So when x equals 0, so this bit here, the equation would equal 0, we'd have minus 4y equals 18. So therefore, if you divide both sides by minus 4, that gives you y equals minus 4.5. Thus the graph passes through the point 0, 0 minus 4.5. Now let's consider when y equals 0. Then 5x minus 4 lots of 0 equals 18, so therefore 5x equals 18. And if you divide both sides by 5, you'll see that x equals 3.6. Thus the graph passes through the point 3.6, 0. Let's add this line onto the previous plot and see what we obtain. So here you can see these two lines, and they intercept at this point here, where x equals positive 2 and y equals negative 2. Therefore, this is the solution to your problem. Now, you can check these numbers by putting them into here. So 4 lots of positive 2 is 8, plus minus 2 is 6. So therefore, it looks right. And if you want to double check yourself, you can substitute those numbers into equation 2 here. Setting up and solving problems using simultaneous equations. So now, although many exam questions on simultaneous equations will already be set up for you, it is important that you learn how to set them up when needed. This will be the case in chemistry. When you need to use simultaneous equations, then you won't necessarily get a nice set of simultaneous equations that, like we've shown before, given to you. So this section shows you how to formulate such problems, which can then be solved by the algebraic method. So let's look at an example that we could have. So here we're told a theatre has 2 different ticket prices, one for adults and another for children. So we have a party of 6 adults and 10 children. They get charged £38. While for 5 adults and 12 children, that second party is charged £39. So we're first asked, write this information as 2 simultaneous equations, and then secondly we're asked, solve your equations to find the cost of an adult ticket and the cost of a child ticket. So let's go through the solution now. So first we're asked to write out it as 2 simultaneous equations. So we're going to have an adult ticket cost X, and we're going to have a child ticket cost Y. So if we look at the first party, they have 6 adults, so 6X, and 10 children, so 10Y, as you can see, that's what I've done here. And that equals 38. And the second party, well, they have 5 adults, so I've picked 5x, and they have 12 children, so I've done 12y, and that equals 39. So now we have our 2 simultaneous equations written out. Let's now move to part B and try and solve the simultaneous equations. So, as we've seen before, we need to try and get a similar number of x's or y's on the 2 equations. So here I'm going to go for the y route. So the easiest way to get a similar number of y's and a similar number of y's in this equation as well is try and find the lowest common multiple of the 2. And in this case it is 60. So I have to times equation 1 by 6. and equation 2 by 5 because 6 10s are 60 and 5 12s are 60. So that's what you can see I've done here. Equally, if you wanted to do it a different way, you could try and make a similar number of x's. And as I can see here with a 5 and a 6, well, you could times this one by 5 and this one by 6 to give you 30x on both. But that's not the route I took here, but feel free to try that at home if you want to do it yourself. So, by getting a similar number of y's as shown here, because I times equation 1 by 6, so 6 lots of 6x is 36x, 6 lots of 10y is 60y, and 6 lots of 38 is 228. I've done similar for the second equation, but times by 5. So 5 lots of 5x is 25, 5 lots of 12y is 60y, and 5 lots of 39 is 195. I've labelled these equations now 3 and 4. So I can now subtract them from each other. Remember, dash, different addition, same subtract. So you can see the signs are the same, so we subtract. If we do that, we have 36x minus 25x is 11x, 60y minus 60y is 0, 228 minus 195 is 33, and then we just divide both sides by 11 to give us x equals 33 divided by 11, and that gives us the answer x equals 3. Now we need to substitute the x value into equation 1. So we have 6 by 3, because x is now 3, plus 10y equals 38. And that gives us 18 plus 10y equals 38. And then 10y equals 38 minus 18, because we've taken 18 off both sides, gives us 10y equals 20. And we divide both sides by 10 to give us y equals 2. Thus, an adult ticket costs £3 and a child's ticket costs £2. All that's left to be done is to then substitute these values into equation 2. So try that now at home to make sure I've got the right answers for an adult ticket and a child ticket. That concludes part 2 of lecture 3, and it also concludes this lecture.